Today we're going to talk about transformers. We'll talk about what they are and then give you a few examples of how they work. Transformer is basically when a power is changed from one voltage system to another. Transformers range in size from large, used in a utility company's distribution system, or small, that regulate current to doorbells, thermostats, or some lighting. There's a close relationship between a flow of electric current and magnetism. This is why coils, which is a curved wire, are used to create an electromagnet. This is done by having two coils and an iron core to create a transformer. The electricity from the first coil, known as the primary winding, goes through the coil to the iron core and is then transferred to the second coil, known as the secondary winding. That voltage will then get transferred to a load, such as a light switch. The amount of voltage is dependent on the amount of turns on each primary and secondary coil. If the primary has less turns than the secondary winding, it's considered to be a step-up transformer. And the opposite, if the primary winding has more turns than the secondary winding, it's considered to be a step-down transformer. So let's say we have a 2-to-1 ratio transformer, which is a step down since the primary is higher than the secondary. For instance, a 2-to-1 ratio transformer with a primary of 120 volts would have a secondary of 60 volts. Now the amount of current, also known as amperage, behaves directly opposite of the voltage. So if it's a 2-to-1 ratio transformer with a primary of 120 volts with 10 amps, the secondary would be 60 volts with 20 amps, leaving the total watts always the same. So that leaves us with the equation volts multiplied by amps equals power, or watts. Now let's put this equation to use. There's a transformer that gives off a total of 1200 watts. The primary winding gives off 120 volts and 10 amps. This is a 1-to-2 step-up transformer. What would the volts and amps be for the secondary winding? Let's begin. Since the voltage is twice as high as the primary, we first multiply the primary voltage by 2 to get the secondary voltage total. That total would equal up to 240. Since amps do the opposite, we would have to divide the amp, which is 10 by 2. That would equal 5. Now let's test our answer to see if the totals equal the same. 120 volts times 10 amps equals 1200 watts. 240 volts times 5 amps equals 1200 watts. And there you go. This is a simple example of what transformers are and how they work.